All right, this is Utah Middle School Math Project 1.1a, Simplifying Linear Expressions, but this is part 2, just to finish up the last little bit of the lesson that we didn't get to finish up in the last video. We left off getting ready to simplify these expressions down here. Again, we practiced simplifying expressions where all we had to do is just combine like terms, like up here, finding zero pairs, combining like terms. We also simplified some where all we had to do was distribute, and this is where we start putting all of those skills and doing both distribution and combining like terms. And if you're ever confused on what you need to do first, please make sure you always follow that order of operations. Whenever you're simplifying, we're always looking at the order of operations. Just like when we're building equations, trying to figure out how the equation is built, we look at the order of operations. We do the same thing with simplifying expressions. So on number 6, are there any grouping symbols? Yes. But can you simplify what's inside of the grouping symbols? Can you combine x and 2? No. So those grouping symbols are there for another reason. So although yes, there are grouping symbols, we can't do anything with those grouping symbols, so we're going to move on. E for exponents. Any exponents? No. M for multiplication? And yes, thank you for that correction. Multiplication or division, is that happening in here? Yeah, it's happening with the parentheses. That's what that distribution is it's two groups of x plus 2. So the parentheses are there not because we can simplify what's in them, but because we're multiplying everything inside of the parentheses by 2. So in the past, we would kind of model this by saying this is two groups of x. So I'm going to kind of draw a little arc saying I've got two groups of x, but I also have two groups of 2. Oops, I didn't finish up that parenthesis. And my two groups of 2. So that's how I'm showing that work, so that I can move on past from drawing the models, but I'm still thinking it through, that I have two groups of x and I have two groups of 2. And don't forget what we have at the end. That just took care of that distribution where we multiply across the parenthesis. We still have this minus x. So I'm going to bring that down. And now we can officially simplify. Two groups of x does mean we have 2x. And two groups of 2 means that we have 4. But then we have this minus x at the end, which I can call plus a negative x. And now that allows me to look for those like terms that I can combine, 2x and a negative x, which combine to be one single x, which you can write as 1x. Or if you're lazy, you can write as just x plus 4. And number 7, again, following the order of operations. A lot of times students get impatient and they just want to go from left to right. But we have grouping symbols, which means we actually do have some multiplication in there. So go through that order of operations. Grouping symbols, yes, but can you simplify what's inside? No. Any exponents? No. Multiplication or division? Yes. We're seeing that multiplication in the grouping symbols. We have 4 groups of x and a negative 3. So I want to distribute and go across, but I also see this minus 3. So if you're going to try and do this going across, those multiplying across the parentheses without really being careful about that subtraction, you're going to make mistakes. So before we even get started on this one, I want that first step to be, let's get in the habit of changing subtraction to adding a negative. So 3 minus 3x becomes 3 plus a negative 3x plus 4 multiplied by the group x, not just minus 3, but x plus a negative 3. Really make that your habit, that we're changing subtraction to adding a negative. So now, as I'm getting ready to multiply across the parentheses, recognizing that we have 4 groups of x, and that means I can add, and I also have 4 groups of negative 3, we're not losing the sign, we're not losing the operations, we know what those operations are. Now all I did was I just distributed or multiplied across the parentheses. I still want to make sure I'm bringing everything else down. So I'm going to bring down that 3 plus a negative 3x plus, and then we multiplied that 4 across the parentheses to 4 groups of x and 4 groups of negative 3. Now we can actually simplify. 4 groups of negative 3, that's going to simplify to negative 12. 4 groups of x, that just simplifies to be 4x. And again, bringing everything else down, 3 plus a negative 3x plus that 4x minus 12. After we take the time to distribute or multiply across the parentheses, we now are at the point where it's just combining like terms, where we can see we've got 3 negative x tiles, which are going to combine with 4 positive x tiles. That means those will combine to give me just 1 single x tiles, because we're going to end up with some 0 pairs there. And these 3 positive unit tiles will combine with these 12 negative unit tiles. We're going to have some 0 pairs there, so I'm going to end up with a negative 9. This is our simplified expression. This is our simplified expression. Just by thumbs up, thumbs sideways, thumbs down, how did you do on your own prior to us doing it together? Thumbs up means we got it just fine. Thumbs sideways, you learned some stuff as we did it together. Thumbs down, you're still confused after doing it together. All right, if you're at a thumbs down, then you probably shouldn't skip this direction right here, which is model. You can put your hands down. Model. If you're struggling with this, take the time to draw out the models. Okay, next one's to practice. Let's use what we learned from the last one. We are going to change our subtraction that we see to adding a negative. Number 9 is going to be a challenge, so focus on 8, working with your groups. And notice what it says, use the tiles if you need to. So you still can draw models. Eventually, I don't want us to need to draw those models, but if you're still needing it, then take the time to draw the model, because that will clarify all the things that we're doing with these expressions. With your groups, simplify numbers 8 and 9. Don't try and move on to 9 until everyone in your group is satisfied and comfortable with their response for number 8. Any questions before I set you free? Okay, ready, set, go. And pausing the recording. Okay, we're coming back together and we are looking at number 8. From the groups that I saw, most students did just fine on this one. Changing that subtraction to adding a negative. This is how I would read this problem. Negative 4x plus 3 plus 5 groups of 2x plus a negative 1. Again, if we're drawing models, when we're drawing these models, we need to make sure we're drawing our models following the order of operations, always. Whether we're simplifying the expression or drawing the model, we always start with the grouping symbols. So if you're drawing a model, you need to draw those grouping symbols first. Again, I'm going to move past that. I'm hoping that we don't need to continue to use the model, so I'm not going to show the model, but I'm going to show how I would use the order of operations to simplify. We do have grouping symbols here. However, 2x plus a negative 1, if we're looking at algebra tiles, those are different shaped tiles. So I can't combine them, which means the parentheses are there for another reason. And since the parentheses are there for another reason, we can kind of move past that grouping symbol a little bit when we're simplifying. No e for exponents. No exponents here. M for multiplication, that's why those parentheses, those grouping symbols are there, because the grouping symbols are really truly being multiplied by 5, because we have 5 groups of 2x and we have 5 groups of negative 1. So that's the first thing I'm going to simplify. 5 groups of 2x. Taking the time to really show all of the steps. 5 groups of 2x and 5 groups of negative 1. Now, all I did was I figured out how many are there across those 5 groups, but don't forget all of this other stuff, bring it all down. Negative 4x plus 3 plus 5 groups of 2x plus 5 groups of negative 1. Now, what is 5 groups of 2x? Luke, what is 5 groups of 2x? Yep. What is it? 10x. 5 groups of 2 is 5 times 2, which is 10x. And 5 groups of negative 1, 5 groups of negative 1 is negative 5. And again, bring down these other pieces that weren't used yet, because now we're ready to start combining those like terms. I have 4 negative x tiles here. And, oops, I forgot the plus sign in between those. And 10 positive x tiles here. Those are going to combine. 4 negatives, 10 positives, that's going to give me 6x. Then I have 3 positive unit tiles, 5 negative unit tiles, which means those are going to combine, give me a couple of 0 pairs, and I'm going to end up with plus a negative 2, which again can also be rewritten to be 6x minus 2. Now, tie that into what we see over here. You're going to need the same sort of processes, changing your subtraction to adding a negative, as well as one extra thing. 12 minus the parentheses, so that means 12 plus a negative what? Negative parenthesis. We saw this. This is the opposite of the parentheses. I should have changed that to adding a negative as well. So why are the parentheses here? The parentheses are here because it's the opposite of those parentheses. You can still treat this like distribution, because what we're really doing is we're saying we want the opposite of x. And we want the opposite of a negative 2. Bring everything else down. So we're still going to have our 12 plus that negative x plus the opposite of a negative 2, and then bring this down plus the 4x. See if you can finish that up. I'll give you just a little bit to work with your groups. I'm not going to pause the recording this time. A little bit to work with your groups. See if you can finish it up now that I've gotten you started. With your groups. That means we should be talking a bit more. Thank you. Okay, and I hope that this is what you came up with. We have 12 plus, what is the opposite of x? That's going to be a negative x. Or if you would like, you can say it's a negative 1x, if that helps. And what is the opposite of a negative 2? A positive 2. And then we've got our plus 4x. Now we can combine our like terms. We have a negative 1x. We have 4x, that's going to combine to give me 3x. And we have 12 unit tiles and 2 more unit tiles combining to give me 14. This is as challenging as it gets when you have a subtraction right next to the parentheses, changing it to adding a negative, and then remembering, because we did have a problem like this, remembering that this means the opposite of everything inside of the parentheses. So making sure we know how to handle that. Now the next ones I really like because it really gets your brains flowing, makes you think about different ways that we can write this. So I want you to write 3 expressions that are equivalent to 6x plus 12. What that means is I'm giving you the simplified version, unsimplify it and give me something crazy like this. But something crazy that is going to simplify to be that 6x plus 12. You can start nice and simple. Let me help you out with the first one and then you get to write 2 extras. What if I had these 6x tiles and the 12 unit tiles split up into 6 groups? So that means if I have 6 groups, each group is going to have just 1 x tile. And how many unit tiles? Those 12 tiles are actually broken up into 6 groups. Yeah. That is a different but equivalent expression. 6 groups of 1x plus 2 is equivalent to 6x plus 12. Okay, so I did one where now it requires distribution. See if you can come up with some others, maybe that have some distribution, maybe that are just combining like terms. Working with your group, see if you can come up with 2 more. I'm going to pause the recording while students work in their groups. Ready, set, go. As I walked around the room, this is the one that I saw most. Instead of 6 groups, what if we just had 3 groups? If we have 3 groups, how many x tiles would have to be in each group? 2. And if we have 3 groups, how many unit tiles would have to be in each group? 4. I saw that most. I also saw 2 groups. If it's 2 groups, that would be 3 x tiles and 6 unit tiles. But not too many of you got super creative and did some where we didn't need to distribute, where we just combine like terms. Let me give you an example of what that would look like, and I want you to come up with another one. What if instead of 6x tiles, I have 3x tiles here? And then instead of 12 tiles, what if I have 15? Well, since I'm trying to get 6x plus 12, how many more x tiles do I need? Well, I already have 3. Trying to get to 6x. 3x tiles, Mrs. Proctor. Yes, good job. So eventually when I combine 3x and 3x, it's going to give me a total of 6x tiles. And now I have 15 unit tiles, but what's my goal? 12. So what do I need? Plus a negative 3. So when I combine 15 and 3 negative unit tiles, that will give me 12. But remember, we can also write plus a negative as minus 3, and then it's disguised even more. Come up with another one. You guys did good on writing the ones for distribution. Work with your groups. Write at least one more where it's just combining like terms. Ready, set, go. Pausing the recording. All right, just one student to share another one where maybe we're not doing just distribution. Good, thank you. Emery. Did I write that correctly? 28 here at the end. Is that correct? Did I do that correct? Okay. Which one? This one? Plus a negative 1x. Okay. What do you guys think? I think we're fine on the x tiles. We might need to adjust our unit tiles. Let's check 1x plus 6x plus a negative 1x. Do we have the right amount of x's? Yeah, because this x and this negative 1x are going to zero each other out. Let's focus on the units then. We have 30 plus a negative 10. That's 20 plus a negative 28 is negative 8. So I think we need to adjust this instead of plus a negative 28. What if we change it to just plus a negative 8? That gives us 30 plus a negative 10, which is 20, plus a negative 8, which is 12. That gets us where we need to be. Okay, minor fixes, but you got it. Good job. And now, can you guys repeat that process here for number 11? 3 expressions. Be creative. Have some combining like terms. Have some distribution. And if you're feeling crazy, see if you can include both combining like terms and distribution in one expression. That still is going to end up being 4x minus 2. With your groups, ready, set, go. All right. Looking for a couple people to share. And I don't want them to be like super duper crazy insane so that we can still get through this. Okay. So let's start with Timothy. Is the 2x plus 4 in parentheses? Right there next to the 4? 0.5, got it. Wow, okay, should we test it out and see? 4 times 0.5x, that's going to be 2x. And 4 groups of negative 0.25 is going to be plus a negative 1. Yeah, this is going to work. And then after we just do that distribution, we have this extra 2x to add to it and an extra negative 1 to add. Those are going to combine to give me the negative 2, and these are going to combine to give me the 4x. That works. Nicely done. And I like the use of the decimals, not being afraid of the decimals. I like that. Okay, give me another one, Luke. Did I write it correctly? All right, negative x combines with the 12x to be 4x. 10 combines with the negative 12 to be negative 2. So yes, that works. Nicely done. Last one. Caden. Slow down. 8 plus 2x. Yep. that'll get there as well. 2x and 2x are going to combine to be 4x, and 8 plus a negative 10 are going to combine to give negative 2. That also works. Nicely done, guys. And I know there's there are infinitely more options that we could have written, so we're not going to go over all of them. We came up with 3 for our notes, and that is good to go. And now this problem here ties very nicely into our next lesson, which is going to be on writing expressions from a context. So number 12, a group of friends goes to a movie on Friday night. Each friend purchases a movie ticket that costs $8, a small popcorn that costs $3.50, and a medium drink that costs $2.25. You need to go through these expressions and circle all of the expressions that represent the total amount of money spent by the group. The key thing to know here is that F represents the number of friends. Because we don't know the number of friends, it just says a group of friends. So that's why F is our variable, it represents the number of friends. We're looking at the amount of money spent by the whole entire group. So go through those, talk with your groups, see if you can figure out which expression or expressions are going to fit this situation. We'll come back together and discuss in a little bit, but give this a try with your groups first. Ready, set, go. You guys did good work here. Is this one going to work? Why? What does this one tell us? Thank you for raising your hand, Sam. Yes, this is how much one person will spend. $8 for the movie, $3.50 for the popcorn, $2.25 for the drink. So this is how much one person will spend. Is this one going to work? Why? Because it looks really close to what we have up above. Why is it all of a sudden going to work, Danielle? Yeah, that's a great explanation. It's F groups of, we already know that this 8 plus 350 plus 225 is the cost for one person, right? So F groups of the cost, that makes perfect sense. However many of friends or people are there, that is going to be multiplied by the total, or the cost for one person. Is this one going to work? Sorry, let me circle this one. Is the next one going to work? Because it looks really close to the one up above it. So is that one going to work? Why not? Emma? Yeah. Is it okay to just say this is what we're all going to spend, and since there's 10 of us, we're just going to add $10? That's what that's really saying. That's not really going to work. F plus 1375. Is that one going to work? Jaden? Why? Yeah, it's just like the one above it, except it's added all of those numbers to give us a 1375, right? So we're not going to take the cost and add the friends to the cost. How about this one? Is this one going to work? Let's go Maverick. Why? Great. Each item is being multiplied by the number of friends because each friend is going to be buying that item. So yes, that works. Notice the connection between these two, right? Friends times 8, friends times 350, friends times 225. So we've just used that distributive property across the whole set of parentheses. And that's what we're seeing here. And the last one then, is this one going to work? It's pretty much the same as up here. So is it going to work? What are your thoughts? I've heard from each of those hands. Seth, what are your thoughts? Good. So these are all equivalent expressions. First, we distribute. Then, once we distribute, then we can add it all up together. Or we can add it all up together and then multiply it by F, which is what we're seeing here, kind of skipping that middle step. So yes, those are the 3 that are going to work. And now we evaluate. If 5 friends go to the movie, how much money will each person spend? And then how much money will the entire group spend? We already know how much each person is going to spend. Each person is going to spend $13.75. We know that from our previous work up here. But now, all we have to do is take that $13.75 and multiply it by F. Only what is F according to this problem? 5. We're just substituting that value in. $13.75 times 5. You have calculators. Let me know when you have that completed. Great. Charlie. $68.75, is that what you said? All right, $68.75, or in other words, $68.75, turning our abstract answer quantitative. That's it for this lesson. Your homework is 1.1a, that whole entire homework section. That's it. Thanks for watching.